Okay, cool. So we're gonna get there. Right, Julia back. Let me put that iShares here. iShares here. Okay, cool. Right. And of course I want my notes. Up on. Right, so right, Juliana is here. Jada, no. Janaya, no. Right, well. Right, so Monday, as you all know, who was here, was having an issue getting the signal from the laptop that shows on the screen to the streaming laptop for it to show on the screens here and online. So somebody came yesterday and the man pressed 2 buttons and sorted the problem. I'm like, oh, okay. And then today, I just plugged in the thing and the signal went. Normal. So yeah, I paid $450 for, I'm not sure what. But I mean, I was grateful to the guy for coming. He sorted out my problem and then it also fixed itself. But yeah, anyhow. So folks, we are continuing with linear programming today. Today, we're going to deal with one of the parts that gives people trouble. Now, the whole thing gives trouble for some people, but some people, certain aspects give trouble. And just like in a car, if one thing goes wrong, it might throw off the whole thing, right? So we're going to work on this piece today, which is the inequality statements. Turning an English statement into a math statement, right? So I know even from SCA times, or SCA days, some people have trouble with this. Understand, what happened here? Bumped my pens, what are they looking so? Oh, y'all can't see? Okay, sorry, no. Well, I guess they updated. Okay, cool. Let's see if it changes how I write. Okay, so today we are talking about forming inequality statements. All right, so with the inequality signs or the symbols, right, we're going to be using the less than symbol. Sorry. Yeah, so these, I get a little trouble to pressure in the dance, boy. Less than, greater than, less than, equal to, greater than, equal to. Okay, so the first one we're going to talk about is, well, they're not the most popular, but less than. Right? That, for example, most of us are accustomed with, if you score less than 50% on the exam, you fail. All right? So the symbol for this item here is this way, like an arrowhead pointing to the left. All right? Okay? So if I give you if I put a 2 here and a 3 here, right? Would you agree if I wrote the following here? 2 is less than 3. Would you consider that to be an accurate statement? Yes. Okay, cool. So what this symbol allows us to do, it allows us to replace these 3 words with one symbol. As they say, a picture paints 1,000 words, right? Of course, it's a saying. So we could actually rewrite this in this form. 2 is less than 3. Actually, based on my notes last year, I had this in a different color. So let me put it in a different color. All right? Yeah. So 2 is less than 3. Right? So these 2 statements are read out loud exactly the same way. Jeff, watching your videos give me a 1 in POA. Hey, you're welcome, Jeff. 2023. That was a good year. We did a question from that today, the manufacturing question. Right? But congrats on your success. The very last question. No, Steve. Yeah. All right. All right. What about these 2 numbers? 4 and 7. So what can we write here? We can write 4 is less than 7. Again, starting very easily, because I know people have issues with this topic, so I'm not treating you. I don't mean for it to come across like I'm treating like you don't know what you're doing or like you're stupid. That's not the intention. It's to show you we start simple and we build up from there. I'm not taking for granted that people understand certain things, because I've done that in the past and yeah, didn't turn out to it. Right? So 4 less than 7. Right? So if I have a statement now, and I tell you x is less than 4, right? Because as we know, algebra comes into things pretty fast at this level, right? So we can write this as x is less than 4, right? And if we got some other information that x is positive, oh, sure. Right? So if I give you some more information like this, so if I said x is greater than 0, so if a number is greater than 0, is it positive or negative? Positive. So x is positive. Right? And x is an integer. What is an integer, people? A whole number. Right? So we could actually represent this on a number line. Right? So if we had 0, 1, 2, 3, 4, let's stop at 5, right? So to represent this on a number line, what we would do is we would go, so all right, so this thing here, x is less than 4. So we'd put what we call an open circle above the number 4, and less than goes which way? To the left or to the right? To the left. Oops. Nope. Try that one more time. All right, so here, if you wanted an actual solution set, maybe that x is equal to 1, 2, and 3. Okay, all right, so sorry, for those online, I forgot to send you a PDF, but you could actually write all this stuff real quick. Okay, so for those in class, you'll have a handout, right? So let me just find page 1. Right, so on this page, I would like you to basically use the inequality symbol in place of where it says is less than. So for example, the first one, we would write x is less than 5. All right, so I want you to finish off that section for me, right? So from number 2 to number 8, just convert the statement in words to an inequality statement using the less than sign to replace the phrase is less than. Right, now I know it seems very simple, very easy, and that is on purpose. Because again, when we start to combine and put things together, I want you to remember, hey, it started off easy and I could do this. Nisha, hey Sumi, how you all doing? All right, I am Chris. Hey, how you doing? Yeah, sorry, I'm not seeing my YouTube comments because I'm on a different window. But oh no, he gone. Yeah, 0 viewers. My bad. Cool. Aaliyah, Naomi, Lewis. How you doing, Aaliyah? All right, good to meet you. Oh, yes. I got it to crack. Nine, which is 12, 15. So we almost have, we still have seats left in class. Okay. A couple of people called recently for sports, but they were adults. I'm like, no, I'm not mixing adults and kids in the same class. Like, not doing that. Although technically some of you in here are legal adults, but that's a different story. All right. Okay, let's go. Let's do the rest. 2, 3, 4, 5. Right, okay, cool. Right, so if x is less than 7, we literally write x is, less than minus 7. Right, we won't worry about the diagrams for each one because that's just going to take up plenty of time. And that's not the diagram we want right now. We want other diagrams which we will get to. So we'll get to them. Y is less than 10. So y is less. Yeah, if I keep doing that, I'll run out of time. And I don't start later already. Y is less than 10. And this one, minus 5 is less than. So minus 5 is less than x. All right, how are we looking so far? So far, so good? Questions, problems, anybody, anything? No? All right. Google Meet if at any point in time only meant to re-explain them or no, right? But I'll check on you as we go on. Okay, we're going again. 12 is less than y. So we go 12, sorry, my bad. 12 is less than y. Then x is less than 8. X is less than 8. What's the next one? Y is less than minus 4. So y is less than minus 4. And 4 is less than x. 4 is less than x. All right, in class people, we okay with that first batch there? Any questions, anybody, anything? No? All right, cool. Google Meet, so Aisha, Juliana, and Noah, just give them a quick G in the chat if you're good with that, please and thanks. All right, cool. Oh, yeah. So T, you wanted more time. Okay, we jumping back to page 1. All right, I'm gonna put some notes just below here. Give me a sec to just separate a line. All right. So in this section now, we're gonna talk about the opposite of less than, which is greater than. Hold on, Okay, cool. So we're talking about the greater than symbol. All right, so of course the symbol for this is just a horizontal flip of the same less than sign. All right? It's the same symbol just turned around, right? So if I put a 3 and a 2, right? What would go in the middle? The English would be 3 is greater than 2. Again, I'm taking it very simple because I don't want to take for granted that we understand simple things. Sometimes there are holes in people's knowledge, right? And we shouldn't hold that against them. It mightn't be their fault, right? So what this symbol allows us to do is to replace this entire phrase with just, well, that symbol. So 3 is greater than 2. All right? And I'll short circuit the little piece of notes, right? So if we have one saying that x is greater than 5, right? So our inequality statement here would be that x is greater than 5. Right? And we also told that x is positive and x is an integer. Right? So greater than 0 means that it is positive. Well, I mean, if it's greater than 5, then it's also greater than 0 for sure, right? And if it's an integer, that means it's a whole number, right? So if we did have to draw a number line solution for this, right? You could put your 0, you could put your 5. You don't have to put all the numbers between, to be honest. Eh? And what we do, again, you put an open circle above there, and greater than goes to the right. Because that's how the numbers increase. That's how we visually represent the numbers as they go on, going from left to right. Right? Now, the reason we put an open circle, right, is because the solution set does not contain that number. So you can think of the open circle like an empty circle. There's nothing inside the border, right? Nothing inside the circle. So if we had to write a solution set for this, it would actually look it would look like this, right? So x would be equal. So what's the first integer or whole number bigger than 5? 6. The next one is 7, then 8, then 9. Would it ever stop? No. So you put a dot, dot, dot to indicate that it continues infinitely. All right. Okay, right. So that's the notes there. So I'll give you a couple of seconds to finish copy that down, and then we will go back to the handout, the section 2, I think it is. Sorry. Okay, so we're gonna go to section 2 now. All right, so section 2 on the printer that you have there, it has greater than. So this is rightly following as inequality statement. So same thing, right? X is greater than 8. So all I'm gonna do is put X greater than 8. All right, so I want you to finish from number 2 to number 8 in this section here for me, and then we'll go on to the next set of notes. Sorry. Ready? Right, so X is greater than minus 5. X is greater than minus 5. Y is greater than 10. Y is greater than 10. Minus 7 is greater than X. Minus 7 greater than X. So far, so good. Any questions, anybody, anything? No? Okay, let's go again. Right, 9 is greater than Y, so 9 is greater than Y. X is greater than 3. Y is greater than minus 7. And 9 is greater than X. Right? So again, just driving home the point. Right, so third form, but this seems, it is simple, right? I start off simple and I get more complicated as we go along. But how I add things, hopefully it makes it less complicated. But yeah, so feel free to stick around and check it out. Yeah, how are you doing? Okay, in class people, are we okay with this section here? Any questions, problems, issues? No? All right. Jerry, we good there? Far side, CSC fellas, we good? All right, Paige, Nyla, Jaziri. All right. Google Meet, Aisha, Juliana, Noah. If we're good with that, give me a quick G in the chart. Right, nice. I get a nice thumbs up. I get a G there. Oh, thanks for following, Nisha. Appreciate it. Okay, let's go back to the knits. Okay, so notes continued. Right, question here. How many topics will you be covering before exams? Right, so Nisha, after this, I'm actually stopping to revise for mock. And I think after that, when I say revise, we're just doing past papers. This is technically my last topic. So yeah, I hope that answers your question. I did everything else before, except maybe statistics. So I might do a couple of statistics sessions from the past papers. But I'll decide as the days go by. Okay. Okay, so this one now, we are going to be talking about less than or equal to. Right? So this symbol could either look like this or less than. So is the basic less than sign with an extra little underline right there, or it could even look like this. Right? Both of them mean the same thing. Right? Now, the purpose of this less than or equal to is that it is used to indicate a maximum quantity. Right? Or indicates a maximum quantity. Right? Or what could also be called an upper limit. An upper limit, or sometimes they use the word bound, an upper bound. All right? And there are some phrases, some key phrases that they'll use sometimes to indicate that this is what they're talking about. Right? So the phrases that you have to look out for, right? Some of the phrases are as follows. Right? So you might see the phrase at most. Right? You might see also not more than. Sorry. Okay. Now see Jaden saying something there. Right. Not more than. Or they might say no greater than. Or not exceeding. Or a maximum of. Oops. All right. So, for example, like so like maxi taxis that you all travel on the main road, right? So usually they could seat about 12 people, right? So the maximum capacity right? Sorry? Exactly. So the maximum capacity of a maxi taxi is 12 people. Right? So if you let P represent people, right, this symbol, if you want to turn this into an inequality statement, the number of people in the maxi taxi is less than or equal to 12. Right? There's a joke I used to tell back in the day, but now as we are more politically correct, I'm not sure I can tell it. But it used to go like this, right? What do you call 12 Indian women in a maxi? A 12-seater. Like the woman, Indian woman seater, you know. Okay, don't worry, that's all right. Cool. All right, thank you. All right. Oh, I got a thumbs up on this side. All right. Like you can't make sada roti with happy flour, you know, kind of thing. You know? All right. So maximum number, or like for example, you ever had that like you forgot your password or you thought you knew your password and you kept entering it, and you have a maximum number of login attempts, right? So we have which one? You can make sada roti with happy flour. Okay. There's an Indian name which is Sita, right? So a maxi could be called a 12-seater maxi. So if it's 12 Indian women in a maxi, it's a 12-seater. Yeah. Well, yeah. Maximum number of login attempts is 10. All right. So if we let's let capital A be a number of attempts. So the number of attempts is less than or equal to 10. All right. How are we feeling with that stuff there? Making sense? Seeming easy enough? Any questions? Anybody? Anything? All right, cool. So I'll give you a couple minutes. Hold on. What's going on with this thing here, boy? You know why you pulling from that? You You are confused. Stop it. Move. Sorry, I'm not talking to anybody here, by the way. It's just the app. Sorry. So you're doing paper one tonight. Uh, for what subject, boy? Maths. Yeah, boy. This is actually my live class. This is a backup stream I have on TikTok here. Paper ones. Where are the paper ones, boy? I do have some paper one videos available for free. You have to download an app called the Learn It app if you have either the Play Store on Android or yeah, Mr. Charles's app. Right. So if you download the Learn It app, I actually have a section in that in the math section, which is multiple choice. I think I did from 2012 to 2019, and the questions repeat. So yeah, you can view them for free there. Okay. So anybody still okay? I've seen some writing still going on. So we'll give them a couple seconds again. All right. Google Meet, just give me a quick G. So Aisha, Juliana, Noah. If you give me a G, okay, give me a thumbs up. I keep forgetting I have emojis. Okay, how do you do that one? All right. Sorry. I had to get my voice out. Oh, thank you very much. Ooh. Appreciate it. Right. I'll shift and it, right? Uh, where did I section? Right. Okay. So sorry, we're doing section 4 first, apparently. Did I put Atmo? Yeah, I did. Okay. So we're doing section 4. So on your page, we'll backtrack for section 3. Right. I know not a lot of schools do paper 3, but you could do paper 3 in maths or POA. Right. So in this first case here, right, x is at most 12. So at most means x could be 12 or it could be less than 12. Right? So it could be less than or equal to 12. Right. Paper 3. I don't have any paper 3 videos, sorry. I was supposed to record some stuff in the Christmas break, but that didn't get done. I'm not sure what to tell you to look in, but it should have available on YouTube. Any help where as can pay? Nisha, you want to type over that statement? I'm not sure what you mean by that. No. Oh. Once again. Tyrell. Yeah, learn and it is I think it's one word and the it is capital letters. Right. Yeah. But you say you learn it. Yeah. I got an email from them today because I think they want us to put more PDFs and stuff up. We could charge for certain ones and split the thing. I'll see Mr. Charles on a morning running Savannah. I think I saw you all passing me this morning too. Running Savannah. By the same FCB on that side. Upstairs. Make sure you know where you're taking it. Right, so I have found in a blue pack. That good? Okay, cool. Alright. Need my money. Alright, come on. Right, sorry. Is that right? Right, sorry guys. So how come I didn't answer? Performance management, no. Sorry. Nisha, DM me now. I don't give him a number online. Like this, but DM me and I'll give it to you. Okay, sorry. Let's get these done. So x is not more than -2. Not more than means it's less than or equal to -2. Y is at greatest 7. Less than equal to 7. All right. X is at maximum -5, so it's less than equal to -5. 8 is not greater than y, so it could be less than or equal to y, but not greater than. Right? X is at greatest, so x could be 7 or it could be less than 7. Right? Y is at maximum 5, so maximum means it could be less than or equal to -5, sorry, not 5. And 8 is not greater than x, but it could be less than or equal to x. All right. Okay. In class, people, are we okay with section 4 here? Any questions? Anybody? Anything? No? All right. Google Meet, new drill. Aisha, Juliana. No, what is going to be a quick G? All right. All right, lovely. Okay, cool. So we're going back to page 2 to do this piece here. Right, so this is Nisha. Right, so 4. Yeah, this should actually be section 3 because, anyhow. Right, so this one is greater than or equal to. Right, so the symbol here is greater than or equal to, or you could do it kind of more like flat like that. Again, they mean the same thing. Right? So, of course, you have some phrases to go along with it. Oh, sorry, I forgot. This indicates minimum value. Or a lower limit or bound. Or lower boundary, that kind of stuff. Right, so we have some phrases here as well. All right, so we have at least. Right, no less than. No fewer than. At a minimum. Okay. So let's hold on. Let me just see what I did up here. I did a blue and orange. Okay, cool. I'll do that too. right? So example 1. So in a test, at least 50% is required to pass. So let's call the score X. So X has to be greater than or equal to 50%. So can X be 50 and you will pass? Is that true? Yes. Or 51, 52, 60, 70, right. Could X be 49 for a pass? No. All right. And example 2, right? Not less than 12 passengers are required for the taxi to depart. For the taxi to depart. Right? So the number of passengers must be at least or greater than or equal to 12. Right? So if they have 12 people, could they leave? Yeah. 13? Yeah. 14? Yeah. 15? 11? No, because it will not leave with less than 12 people. 10? No. All right? Yeah, so I'll give you a couple of seconds to finish copy that. I'm going to drink some water. Okay, so now we will go to section 3, right? So section 3 is the at least section, right? So at least implies a minimum. So for example, number 1, it says X is at least, I don't know why it says X is at least than 2. That's not correct. Let me see if I could actually get rid of that. Right, so X is at least 2. I had to go and fix that, sorry. I forgot. Right. So if X is at least 2, it means X is greater than or equal to 2. All right. So if you please finish this section here, and then we shall continue. Sorry. And if your name is Joseph, I know I had it, but I don't know where it disappeared. But I wanted to make sure. Right. Jaden has an exam. Right. Jair is here. Janaya is not here. Javi is here. Jaziri is. Josiah is here. Wam to your partner Jaquan. Alright, cool. Wam to your schoolmate. Alright, no problem. Well, what are we gonna do? Alright, Julie is here, Khalifa is here, Logan is here, Noah online with us. Nyla is here and asleep. No? Yes? Okay. Paige is here. Zian is in the corner, right? I said Juliana, yes. I said Aisha, she was first on the roll. And I said no. Okay, cool. I think that's it. Yeah. Okay, cool. I might just respond to Jane real quick and we'll correct this section, right? Okay. Ooh. All right. Let's correct this batch and move on. Okay, so x is no fewer than 8. No fewer than is no less than. So x is greater than or equal to minus 8. Did I say 8 before? Sorry. Y is not less than 9. Not less than means it could be greater than or equal to 9. Right? X is at minimum. A minimum means it is greater than, it could be greater than or equal to that item. Okay, going again. Y is not lower than 7. So it's greater than or equal to 7. X is at least than here. X is at least 2. Right, so x is greater than or equal to 2. Y is no fewer than minus 8. Right, and x is not less than 9. So it could be greater than or equal to 9. Okay, are we okay with this batch here? Yeah? Logan, Jair, Treasury, Donovan. CIC fellas on that side, we okay there? For front row? Okay. Aisha, Juliana, Noah. Let's give them a quick genie chat to figure with that, please and thanks. Alright, cool. Okay. So we're going back again. Right, so I have 2 more sections of notes. Sorry, one sec. Sorry? Okay, that's no scene. If you had to go, you had to go. Right, so we have 2 more sections of notes. So we have, okay, let me just get into it, right? Because I think we have, hold on, that was 6, right? So we have 7, no. So we have page 8, page 9 to do, and then we have, okay, cool. Okay, so okay, so hold on. Between excluding and between. Okay, cool. Right, so number 5 is greater than but less than. Right? So what's happening here is we're going to have a minimum value, right, and a maximum value. And what we want is going to be between, but it's going to be exclusive of those values. Oh, thank you, KSIC. I appreciate the kind words. Right, so I also refer to this as exclusive of. Sorry, let me rewrite that a little more clearly. Right, exclusive of. There's a little highlight there, right? Okay. Right, so this indicates a range of possible values. also indicates the endpoints. Hold on, indicates a range of possible values between two endpoints. Sorry, between two endpoints. Which are excluded from consideration. All right. Let's get a couple of examples going here, right? So example 1. Right, so let's say for a particular taxi to leave, they need more than 3 people, but less than 10. Right? So correct. But they need more than 3. So the minimum number you could have is actually 4. More than 3 people, but less than 10. Correct? Right? Now, you could put it like that, but because of how they presented it here, right? So the minimum, the minimum number of people, right? Sorry, you had to be greater than 3. But that's not the minimum. As Logan was saying, the minimum would be 4, right? And the upper side of it, as in you can't even reach to 10. You had to be less than 10, right? Now, you could also write this as this. All right, so these two statements are indicating the same information. They're just read in the opposite direction. Right, so either P is less than 3, P is greater than 3, or 3 is less than P. And what we do is we could combine these two into a single statement, where we say 3 is less than P, which is less than 10. So 3 less than P less than 10. And if you wanted to indicate this on a number line, right, what would happen? So you put your say 0. So your 3, and let's say a 10 here. Okay, later. Next week then, right? All right, have a good weekend. I'll see you. Get some rest. All right, so the number of people could range from 4 to 9. So 4, 5, 6, 7, 8, and 9. All right, if you want a second example real quick. So X is more than 5, but less than 20. Sorry. Right, and how you would notate this, right? So more than 5, right? So X is more than 5, but less than 20. Right? Some people like to start with the X. So what they'll do, they say, okay, well, X is greater than 5. So they'll technically read right to left. And then they say, but less than 20, sorry. And then they'll go back going left to right. So X is greater than 5, but less than 20. Right. So this is where people start to get a little issue understanding things. So if you think you're not too clear, you can let me know. I'll see if I could explain, re-explain, whatever the case is. I'll pass a little separator line here one time. But right after you copy this down, we're going to go back to the handout. I think this will be on the back of the page now, or the second page, or the second sheet. Section 5, right? But we'll go shortly. Let me just check. Something, sorry. Chelsea, hi. What days do you like? Monday, Wednesday, Saturday. I think I do a form for accounts on a Thursday, 4 to 6. Yeah, but just yeah, Monday, Wednesday, and Saturday morning, 10 to 12 is a keep accounting class. But Monday, Wednesday, 4 to 6 is PUA, and half 6 to half 8 is maths. And I might start back streaming the ad maths class. Okay, cool. Yeah,
Am I getting paid for today or should I not call?
I'll go upstairs and get it for you, right? Yeah, okay, so we're doing section 5 now, right? So here, it says x is between 5 and 12, right? So it says write the following statements as inequality statements, right? So x is between 5 and 12, right? Now, if that's the case, x is clearly going to be greater than 5 but less than 12, all right? So I want you to try the rest for me, right? So while you're trying that, I'm just going to run upstairs real quick and get something and come back. Guys, look at each other. Let's plug into the wall now. Last week, Wednesday, someone left the iPod charger. Sorry, AirPods. Nobody? All right. So I do.
Thanks so much, Chris.
Yeah, that's a good thing to do. Compare it. Formula MD. NMD. Right. Let's get this done. And the last batch of notes. The next section is the last section of the handout, and then we'll actually start tackling some past paper questions. Right? X is more than 2, but less than 9. So X is more than, so if you want, you can write them. So X is more than 2, but also X is less than 9. So if you notice, right, on a number line, it will go 2, 3, 4, 5, 6, 7, 8, 9, going left to right. X is more than 2, so it'll be to the right of 2, but less than 9, so it's to the left of 9. Then Y is between minus 3 and 8. Minus 3 and 8, Y is between. Y is clearly greater than minus 3, but less than 8. All right. X is greater than minus 5, but less than minus 1. Right. So X is greater than minus 5, but less than minus 1. Okay. We're going again. Y is less than 9, but more than 3. So Y is less than 9, but more than or greater than 3. X is between minus 2 and 6. Minus 2, 6, X is between. Clearly less than 6 and greater than minus 2. X is greater than minus 8, but less than minus 2. So greater than minus 8, but less than minus 2. So to the right of minus 8, but to the left of minus 2. And Y is less than 10, but more than 2. Okay. This section here, you all okay with these solutions written up on top there? Yeah? All right, Jair and Javier, you okay with that? CIC boys, you okay there? Uh-huh. Okay. Aisha, Juliana, Noah, yeah? Mark G. And how about you? All right there? Okay. Right. Right. So, like I said, I have one more little piece of notes, which is just going to modify section 5 slightly. Right. So this one is greater than or equal to and less than or equal to. Right? But in this case, hold on, the parallel notes. Isn't it? You're gonna have a minimum value, a maximum value, right? But this here, it will be inclusive of. So the values can be included, eh? Right. So this indicates a range of possible values again. And also indicates right that the endpoints yo but in here no. Included, right? in consideration, included. Right. All right, so this could look like this. It could look like A is less than equal to B, which is less than equal to C. All right? So the endpoints, right, A and C, are considered as possible values in the solution set. Right? The example I give here comes with a story. So back in the day, my dad was the captain of the B side of a cricket team called the Merry Boys down the road there. And there was a fellow called Kenny. Kenny was, how to put this boy, not horizontally challenged. Right? He was a big fella. He could eat, you really eat, right? So one day they had a bet. So they was arguing about who could eat the most doubles. And they had a doubles man right by the savannah on the road. Right? Anyhow. Yeah. So what they tell him, they tell the doubles man, stop selling. Kenny going to eat everything else you have. If you could finish everything you have, we will pay for it. If you can't finish, he had to pay for everything you eat. Well, Kenny had, let me put it this way, Kenny win the bet. Right? How much it was? It was 25 doubles, 8 aloo pies, and 5 apple J. Yeah. All with pepper. Yeah.
He was clutching the toilet.
Boy, here now. Right? So, but he had to, the thing was, he had to eat at least 10 doubles. Right? But not more than 25. Right? So we will let D, the capital letter D, represent the number of doubles, right? So at least 10 doubles means it could be greater than or equal to 10. Not more than 10 doubles means it has to be less than or equal to, 25. Less than or equal to 25, right? So when you combine, so again, you could write this as 10 is less than or equal to D. So when you combine these two things, when you combine these two things now, you get that 10 is less than or equal to doubles. The number of doubles and less than or equal to 25. Everybody. Right. In class, people, we okay with the notes there? We understand that it is between but inclusive of the n values, right? Google me, just give me a quick G in the notes, right? So keep it, yeah, no problem. I'll leave it up for a minute and a half or so, if so long. All right, but we're going to the last page of the handout. Go ahead. All right. Yeah, sorry, yeah. I was just answering a question number 4. Right. So we go into, right, so the last section, section 6 on the handout. So write the following statements as inequalities. So x is at least 2, right? So x is at least greater than or equal to 2, but at most 8. So it's less than or equal to 8. So of course, when you put them together, x is at least 2, but at most 8. All right, so I want you to finish 2 to 8 for me. We'll correct that, and then I'll have some past paper questions we'll take a look at. Well, Adize was that song, and not some of them questionable dancehall songs. Oh. Hello. Or? Okay. All right. Sorry. Right. Let's organize this. Y is no more than 12. So it's less than equal to 12, but no less than 3. So y is greater than equal to 3. X lies between -4 and positive 3 inclusive. So it means it's greater than or equal to minus 4, but less than or equal to 3. X is not greater than minus 1, but not less than minus 9. So not greater than means it could be less than or equal to minus 1. And not less than minus 9 means it could be greater than or equal to minus 9. Y is not less than 3. Not less than 3 means it's greater than or equal to 3, but not more than 9. So it could be 9 or less, so less than or equal to. X is between minus 2 and 6. So X is between minus 2 and 6. Inclusive means it's less than equal to and greater than equal to. X must be no less than minus 3. So no less than means it could be greater than or equal to. Sorry, I was supposed to change my color there. My bad. No less than, so greater than or equal to, and no more than, so less than or equal to 12. All right, Y is at least minus 3, so greater than or equal to minus 3, but at most 7, so less than or equal to 7. Okay, in class people, we okay with this last batch, yeah? All right, Jerry, Javi, good there. Nyla, Ziri, CIC fellows on the far side, we good with that? Right, Aisha, Noah, and well, I guess Julie one. But so, let's give him a quick Genie chat, please. One sec. Okay. Thank you. Okay. Okay, so we have 12 people. All right. Now we're only going to be working from we're working from some past papers, right? But we're not using the whole thing because all we're doing is we're going to be looking for the statements, right? Five, 2, 7, and 2 is 9. 1. I have 4 of them in all, so I'll just print as them. So when you finish, give that out. I'll put it into Flash. Yeah.
I can't really boy is going to be there tomorrow, but he was doing the same inequalities as well. So I was just going to give that to him.
Fareed.
Fareed, yes.
Oh, I have another Providence girl to add to the Thursday.
Okay.
I don't know if she'll start tomorrow, but the mom wants her to start ASAP because she's kind of lagging there. So I was hoping we could probably pair her with Liliana.
Okay. I don't mind. That's fine.
All right, so we're going to use this first one as an example, and we're only going to be focusing. Sorry, one sec. Right, so we're only going to be focusing on the part outlined in orange at the top there, right? So that's all that's going to be relevant right now. All right, so this is an example. So this is from January 2002. So I don't think any of you all were alive at that point in time. All right. Okay, so let's take a read, shall we? All right, so those online could also take a look. So it starts off, a boy wants to buy X ties and Y shirts. Now the reason they're telling you that is because thereafter you have to plot a graph. As we know with a graph, you have an X-axis and a Y-axis. So they're giving you this variable to be your X variable, your horizontal variable, and this to be your vertical variable. So he's buying X ties and Y shirts. So he can buy 2 ties and 5 shirts, or 6 ties and 2, whatever the case is, right? Now, look at the first statement here. He must buy at least 2, but no more than 6 ties. That looks like the exercise we just did. So he must buy at least 2. So he could buy 2 or more, right? So X will be greater than or equal to 2, but no more than 6. So he could buy 6, but he cannot buy more than 6. So what will happen here, right, is that X would be less than or equal to 6. But of course, hold on. We know we have to combine these 2 into 1, right? So what would that look like? It would look like X is greater than or equal to 2, but less than or equal to 6. Right? So this is what they'll do. Now, to be honest, since 2015, which is when they started, well, 10 years ago, wow, when they started printing the papers for you all to write on them, they've hardly brought linear programming, right? For what reason, I don't know. But they have brought at least this piece, which is the creation of the inequality statements. They've brought that at least a few times. The full question, sorry? It comes in paper 3. Okay, right, yes. I don't know if anybody here writes in paper 3 in May, June, but but we'll do it because you never know what they're going to bring. Because sometimes they, for example, in the 2015 and a couple of years thereafter, they brought back scale drawings, which we hadn't seen for a couple of years well. Right? The syllabus is huge. They cannot possibly test every single topic and subtopic on every paper. So they'll pick and choose, right? Even section 1, which is consumer arithmetic, right, is huge. They can't test everything all the time. They pick 1 or 2 topics and put it. And you never know what it's going to be. So you have to know all. All right? Okay. Right, as the first one. Now, the next one down here says he must buy at least 1 shirt. Now, let's go back to the top here. Shirts. Is shirts X or Y? Because I want to know. Yeah, so yeah, shirts is Y. That's correct. So at least 1 means he could buy 1 or more, right? So the number of shirts could be greater than or equal to 1. We okay with that one? Okay, 2 people, thank you, right? All right, thank you, right? Now, the next one here is interesting. Actually, hold on. I'll put the first half in yellow. And I'll do a different color for the second half. Let's do a green. Okay, so I've just highlighted a yellow piece and a green piece. This is what I call, what I like to call the budget constraint or the expenditure constraint, right? The boy has how much money? $196 to buy ties and shirts. Here's my question. If you have $196, can you spend $195? You can spend $100. You can spend $2. Could you spend $197? No. That would be interesting to see. All right? Right. So the total amount of money the boy spends must be less than or equal to 196, right? So I'm just gonna put a temporary statement here, right? So I'll put E for expenditure. So E must be less than or equal to 196, right? Okay. Now the part in the green, it says a tie costs $14 and a shirt costs $28. Okay. Cool. What was that? Okay. Right. So the amount of money spent on ties and shirts together is the total expenditure. And that cannot exceed $196 because that's all the money he has available to spend. So, but how do we create this statement with the money spent on ties and the money spent on shirts? Right? So you can't just say X plus Y because X is the number of shirts. Are we talking about a number of shirts and ties here, or is this the amount of money? Right? So let's put a dollar sign to clarify that, right? So you cannot spend more than that. Okay, check this, right? Yeah. Okay. So you have $14 for every shirt. Now, if you bought one shirt, how much money you spend? Sorry, 14 for a tie. If you buy one tie, how much money you spending? 14, right? If you buy two ties, you spend 28. If you buy 10 ties, you spend 140. How am I getting those figures? I'm multiplying the price by the quantity, right? Or the number of shirts, right? Number of ties, my apologies, right? So if I take the 14 and I multiply by the number of ties, I will get the amount of money I'm spending on ties. And I can do a similar thing for the shirts. The shirts cost 28 and I'm buying Y shirts. So the total amount of money spent on shirts is 28 multiplied by Y. And when I add the money spent on ties to the money spent on shirts, that gives me my total expenditure. And that must be less than or equal to $196. Right? So that tends to be one of the slightly more involved pieces of the question. Right? We have a lot more to do and to cover, so don't worry, we'll get there. All right? But before I do, anybody have any questions on what I have on the screen currently? Right? Just give me 1 sec. I'm just going to shift to the next question. I'm going to print this for you all real quick. I'll shift back so you can finish copy down what you have to copy down, right? Five and 4 is 9 and 3 is 12. Right, so if you didn't finish, take it down, right? So and while you're taking it down, the next question will print and Michelle will give it out. All right. Donovan, how are we feeling with that stuff so far? All right? Logan, how about you? You okay with that? All right. Jerry, you okay with that piece there? All right. Well, okay. So anyway, next year on. So my wife first started watching Grey's Anatomy on one of the streaming services we have, and there was a character called Lexi. Nisha went to it. Okay. Let's take a little read of this one. All right, this one's a little easier, I think. Right, so Mr. John makes X here. So in case you're wondering what year this is from, I don't know. Probably 2003, to be honest, right? So Mr. John makes X cakes and Y pies each day. 1 sec. Sorry, I'll put this on the print too. All right, so we'll see if we can do these two and then we call it a day. How about that? All right, so Mr. John makes X cakes and Y pies each day. In order to supply his customers, he does the following. He makes at least 2 cakes each day. Okay, so at least 2. So can he make 2? Yeah. Can he make 3? Yeah. What about 1? No. So X is cakes, right? So X must be what? Greater than or equal to 2. Okay. He must not make fewer than 3 pies each day. So that's a different way of saying something similar to the above statement. He must not make fewer than 3 pies. So can he make 3? Yeah. Can he make 5? Yeah. Can he make 2? No. So he must not make fewer. That means it must be greater than or equal to. Only one printed though.
Oh, yeah.
Come on 1 sec. When I finish correctly, so you can give it out, right?
Okay.
Right, so pies is Y. So Y must be greater than or equal to 3. Okay, all right, so now comes the budget constraint, right? The expenditure statement, right? So he has no more than $72 to make the cakes and pies. So all he has is $72. So can he spend more than that? No. So the amount of money the expenditure must be less than or equal to $72, right? Okay. Now each cake costs $6 to make. So it costs $6 to make 1 cake. So if he makes X cakes, what would be the expression to represent the total money spent to make? 6X, right? So it costs 6X to make X cakes, right? And you're going to add to that the expenditure on pies. It costs $10 to make a pie. How many pies are we making? Y pies. So it costs 10Y to make all the pies. And that must be what? Less than or equal to 72. Very good. Okay, in class, people, are we okay with that one? Any questions, problems, issues, anybody? My far side, see, I see guys in the front section here. You're rested now? All right, you're going to probably watch your replay, right? All right, fellas in the back, we okay with that? All right, Aisha, no, let's give me a quick G. If you're good with that, we have one more question to go. If you need me to re-explain, tell me. I don't mind, it's not a problem. I don't mean to make it sound like a Russian. All right? Okay. All right, cool. All right, so there's the last question. So I'll give you all 2-3 minutes to take a little read, to write down any statements you could come up with. Now, I would ask you please to keep these same papers safe if you can, right? If you can't, we'll put your name on, we'll staple them, put your name on the first one, we keep it in another folder for you, right? Because I'm going to be working from these next week. That was my question, by the way. When I looked at my plan last year, I realized I actually stopped syllabus work right after bearings and just did past papers until mock last year. And I did linear programming in the Easter break. So what we could do is we could actually just do a day or 2 of linear programming past paper questions and then start past papers to revise for mock. You all want to do that? Yeah? Okay. Well, thanks one person. Okay. All right, cool. Yeah, so I think that might be a good idea since mock is probably going to be just after Carnival. So we'd have 4 full weeks, right? And that's all they fit in the week before Carnival, which is called Carnival Week. So I know the Wednesday me and my wife used to go Punchy Wednesday. And we went and a bunch of the girls from lessons was there. They went to my, we are Chris's favorite students. Like, yeah, okay. Yeah, no, sim. All right. So tomorrow,
4 o'clock.
4 o'clock, and add maths.
Possibly tomorrow.
I'll see the mom message me back.
Okay, cool.
If not, yeah. But we have last week we had Sarah, Fareed, and Liliana. No, Zoe came Friday. Fareed.
Fareed.
Right. So Zoe might turn up. Sorry, Mia might turn up tomorrow.
Mia's the oldest.
Yep.
Really?
Yep.
That's shocking.
Yep.
I didn't know that. I did not expect that. Okay, cool.
How can
So,
message me?
if you don't mind, can you just send me the beginning notes today with the different things, the info?
Right. If you don't say, just message me because I'll create a PDF with the notes after class and send it. Right?
Perfect. Thank you so much.
No problem.
Hi, everyone.
The YouTube name is the same as Adaptation, but I can't really get messages on YouTube. I mean, you could comment, but if you want to talk to me, you can email me. Or just DM. You can DM me here too on TikTok or Instagram. Same handle, Adaptation. All right, folks. Let's get this done quickly because I know the situation with the cars outside is a little sticky, and it have people inside too. All right. So a vendor buys X kilograms of peanuts and Y kilograms of cashew nuts. Email anytime. I want to have a chance to get back to you. Right. To get a good bargain, she must buy a minimum of 10 kilograms of peanuts. A minimum means she can buy 10 kilograms or minimum means you can't buy less than that. Yeah. So peanuts is X, right? So X has to be greater than or equal to 10 kgs. And a minimum of what? 5 kilograms of cashew nuts, right? So cashews is Y. So that has greater than or equal to 5. Now, it says she buys no more than 60 kilograms of nuts. No. That's just the quantity. Right. That's just the quantity. Right? So that one is peanuts plus cashew nuts, the kilograms, must be less than or equal to 60. So that part in yellow wasn't the budget constraint. That part in yellow is just the total quantity of nuts, peanuts and cashews. So peanuts cost $4 per kilogram. Cashews cost $8 per kilogram. And she spends at least $200. So this is like a kind of reverse. Normally you have a maximum money you could spend. Here you say, hey, she had to spend $200 or more. So the peanuts is X and it's $4 per kilogram. So $4 multiplied by X kilograms of peanuts plus $8 per kilogram of cashew nuts. So this total expenditure must be greater than or equal to 200. Okay. Cool. Right. All right, folks, we gotta put a pin in it there for today. Right, so next week we'll do 2 days of linear programming participle questions, and then we will stop the revise for mock by doing whole past papers. It takes about 3 days to go through our whole paper, so we'll aim to get through 3 papers before mock exams. We'll see how it goes, right? Anyhow, folks, if anybody has any questions and they get to ask during class, any issues, please feel free to WhatsApp me. Other than that, have a good evening, have a good weekend, get some rest. I'll see you on Monday. Bye. Yeah, I shall go on there later. All right.